Hey guys, it's Miss Wiesner. I'm going to give you a short tutorial about equations for linear functions and what's good about some and what's not so great about some, and if there's any shortcuts. Well, probably the most popular form is the slope-intercept form, or I call it y equals. That gives you the slope very easily. It gives you the y-intercept where it's going to cross the y-axis very easily. And most graphing calculators require that you put equations in slope-intercept form, so you need to do a little bit of algebra before you can do that. So that's slope-intercept form, and I'll give you some example in a second. Okay, so here's the standard form, y equals mx plus b. So your slope is the m, your y-intercept is the b, and then your x and y are just coordinates on the plane. Okay, so here's an example. Y equals 3x minus 2. Maybe I need to rewrite that one. Okay, so the slope is 3, because it's right here. And then the y-intercept, though, is negative 2, because our regular formula has it plus, and since this isn't plus, we need to make it negative 2. So theoretically, if you had to graph an equation, you could plot the point at negative 3, and then you use rise over run, up 3 to the right 1, up 3 to the right 1, and graph an equation that way. You can tell it's early because I said you could start at 3, and this is clearly negative 2. And plus, this, I should have said standard slope-intercept form, but I didn't. So just bear with me. It is like 2:30 in the morning. Another common form that you see is standard form. Many equations are written in this form, but you have to solve for y to use mainly to put into some graphing calculators, except the TI Nspire, which you have to get the one that has the no CAS, that's the computer algebra system or something like that. But unless they've changed things in the last couple of years, you can use an Nspire on any end of course test or SAT or ACT or whatever, as long as it doesn't have the CAS, the computer algebra system. But let's say you have just a basic graphing calculator, or you have to do it by hand, whatever. So here's your standard form, and then this is an equation that is in the standard form. So you can do this the old way by getting 4y by itself. So what you have to do is minus 3x to both sides. So I'd have 4y equals negative 3x plus 4. I just put the negative 3x where it belonged. And then I have to get rid of the 4 that's with the y by dividing every single thing by 4. So my final equation in slope-intercept form is y equals negative 3/4 x plus 1. It's not bad. You just need to be a little bit stronger in algebra to do it this way. Okay, here's the same equation. No, here's the same equation, but using another way. This is my hint. I don't know why they don't teach it like this, like they used to when I was in school. So you take a and b, and you make that a fraction. And then whatever it is, you're going to do the opposite. So if I put a over b and it ends up being negative, then my slope is going to be positive. So if I put a over b and it's positive, then my slope is going to be negative. So it's the opposite of a over b. And then the y-intercept is just taking the c and putting it over the b. And sometimes you might have to divide it out, make it a fraction or whatever. So my 3x plus 4y equals 4. So I'm going to put that I'm going to pick out the slope from this, pick out the y-intercept from this, and then I'm going to put it in slope-intercept form. So 3 over 4, but notice that it's positive 3 over 4, right? So I need to make it the opposite of that. So that's why it's negative 3/4. And then the y-intercept is 4 over 4, which is 1. So if you plug this into the slope-intercept form, it's y equals negative 3/4 x plus 1. And then you can plug it into a calculator and it would graph the line for you. Let's look at another one. So if it's 2x minus 3y equals 12, I'm going to use the opposite of a over b and c over b as my slope and y-intercept. So I have 2 over, and this would be negative 3. So I have 2 over negative 3, but remember I need to do the opposite of that. So it's positive 2/3. My y-intercept is 12 over negative 3, because that negative goes with that 3, because my initial form is addition, so that means that I need to include that negative. 12 divided by negative 3 is negative 4. And then you just plug it into the slope-intercept form. And I noticed when I did that, I changed it. I didn't do y equals 2/3 x plus a negative 4. I mean, you could, but it's just not proper. This is that same equation doing it the solve for y option. So to get y by itself, I just subtracted 2x from both sides. So that left me with negative 3y equals, then I had negative 2x plus 12. Then I have to get rid of the negative 3, I have to divide every single thing by negative 3. Well, negative 2 over negative 3 is positive 2/3. 12 divided by negative 3 is negative 4. So it's the same exact equation. It just depends on if you want to solve for y or if you want to do the shortcut way. All right, here's what your two calculators look like, the Inspires that I was talking about. The TI Inspire CX, if you looked closely, that's all you would see up here. And this one allows you to enter equations in slope-intercept form or any kind of form, standard form or any kind of form. This one you can't use because you see that CAS there. That's another Inspire, but it does algebra systems, so that's not okay in testing situations. So if you know your rules and you look at your allowed calculators when you're taking the end of course test or you're taking the SAT and ACT, and they have online graphing calculators that don't allow you to plug it in standard form, and you have one of these, then I would ask to use it. Okay, for some reason, my calculator, my Wi-Fi went out, I guess because it's raining. But, what was that equation that we were doing? 2x, so what you would do is you'd hit 2x plus, oh, it wasn't plus, it was minus 3y equals 12. And if you look, it has graphed the equation. Now you can adjust it to see if it really does give me the same slope and if it gives me the same y-intercept. Remember we said the y-intercept was going to be negative 4? Well, there it is. And then the slope, if you go up 4 and to the right 6, 4 over 6 is the same thing as 2/3. So you can graph in standard form on Desmos. Okay, I'm going to see if I'm going to try my luck here and see if you can do a different kind. So if you look at a crazy equation like this, 10 and then in parentheses x plus 3y equals 2y, you can plug that in to Desmos and it graphs the equation for you. I just proved it because I worked it out algebraically, and in slope-intercept form it's y equals 5x plus 3, and you can tell that my line has a slope of 5. It goes up 5 and to the right 1, and it has a y-intercept of 3. So looks like you can enter equations in any form on this one. So that's pretty cool. Except that I was so excited, the equation is 10 times the quantity of x plus 3/5, and that equals 2y. I don't know what I was reading out to you earlier, but it's still pretty cool. You can also, if you don't remember this, you can Google Desmos graphing calculator, and this is what you'll get. If you want just a plain calculator, you can do desmos.com/scientific, and that gives you a scientific calculator. So desmos.com calculator, if it's the graphing calculator, calculate, good Lord. You can use equations in standard form and basically any form.